All right, so it's hard to believe, but the last week of class is here. So let's just take a quick look at the syllabus so we're sure everything's on schedule to finish up. I went in and did a little grading yesterday, and a lot of people still have not submitted Summary 3. That's going to be my principal responsibility grading, so just get it in as quickly as possible. I am going to be leaving town on the 18th and driving, so I'd really like everything in before that. I can grade remotely, and grades are not due until the following Tuesdays. That's 19, 20. My grades are due on the 22nd, but I'm going to be on the road, quite busy with limited access to doing that. So please get.
So that's next Friday?
I leave on the Friday of exam week, which is a week from this Friday.
So Thursday, you should be in Thursday.
Yeah. Yeah, and I can't really guarantee if you put it in Thursday that I'm going to be able to get to it. Well, I will get to it, but it's just going to be more of a challenge for me to grade. Okay, so Summary 5 was due last week, and Exam 6 will be launched on Thursday. Right? Does that answer your question?
Yeah.
Yeah. Okay, and then. I'll give you that final exam. It's optional. I'll leave it open for about 24 hours. If you want to take it online, no problem. So you got like really a full day to take it. And I don't think I have the date for the final schedule, but I'll let you know. We'll have it during a convenient time next week.
If our grade is still good, it can do nothing but help us to take it, right?
The final can only help. It cannot hurt your grade.
Okay, excellent.
Yeah. Yeah, and the final will replace your lowest exam grade. That's what it's used for. Okay, there we go. So let's get into this last chapter, and just a couple of things that happened just this morning. I don't know if you ever listened to KBGO 101.5. It's the more conservative radio station. So Rush Limbaugh's on there, Sean Hannity. There's also, in the morning, there's a show called Talkback. A colleague of mine, Bob Seidenschwartz, here in town, had Patrick Barkey on. Barkey is the economist at the university that does sort of the economic report for the state. And a couple of weeks ago, he was bemoaning the Clean Power Act, saying that it was going to damage Montana's economy because Colstrip was going to be shut down, et cetera, et cetera. And the Clean Power Act does not call for the shutting down of coal-fired power plants necessarily, or if it does, it shouldn't, because we all need electricity, but I think we all can also agree that we need carbon-free or carbon-neutral electricity. And so what I said on the radio this morning is that I would like the debate to become less polarized and actually move towards a solution where we can begin to wean ourselves off of fossil fuels. And the point that I made, I'm not sure who. I think it would be difficult arguing with the point that I made, which is that if these fossil fuels are as valuable as we say they are, and they are, I mean, they're allowing us to communicate right now, that we should save them for future generations and not burn through all of them as quickly as we currently are. So I think what we need to do is come up with solutions that are good for the economy as well as good for the environment. And I think that's pretty tough to argue with. And the solution that I've mentioned several times is this one of removing a lot of the hazardous biofuels from the forest, so going in after the beetle kill, turn that into a biofilter, similar to some of these algae sequestration technologies where you actually have a living filter that's metabolizing that CO2, and then you can further, so rather than pumping the CO2 into the atmosphere, it's now recaptured either in in a metabolic process or in a solid or liquid form, and then that carbon can then be used as an agricultural product or another high energy product. So really utilizing the biofuels. And so now you've mitigated the forest fire problem, which is just wasting all of that biofuel and damaging soils potentially, while creating more jobs. Patrick Barkey also mentioned that the trucking jobs are hurting a little bit right now because the commodity market is not as great. And he also mentioned that, somebody else mentioned this, but this was last night, that this year, and you guys, especially since you've just done summary 3, this year global CO2 emissions might be less than last year's. And yeah.
Just because of that?
Well, a couple things. There are a lot of new renewable energy technologies are coming online. Solar continues to grow, wind continues to grow, but that if the commodities market declines, if people buy less stuff, then less stuff gets made in China and shipped across the ocean. There's less carbon footprint with that too. So there's a variety of things that go into it. Okay, so with that, I think we're safe to start in on Remedies, Chapter 14, Towards a Sustainable Energy Future. And if you've been following the Paris talks, I'm pretty encouraged by what I'm seeing coming out of there, especially with the private sector. My daughter follows Arnold Schwarzenegger. He was a big proponent of the hydrogen economy, and there was Arnie with his arm around Ban Ki-moon saying, "Oh, everyone should support so." And for whatever that's worth, I mean, these are some rich, powerful, influential people who I think are now hopefully putting their money where their mouths are, just like Bill Gates just announced he would do too. Okay, so I'm just going to read a little bit from the first paragraph here on page 571. It says, this final chapter considers how the sustainability problems of our present uses of fossil fuels might be mitigated. Obviously, this will require technological, I just mentioned one, our biofilter, and socioeconomic changes. What's that mean? Well, it means taking the bus or riding your bike versus being in a personal passenger car. It might also mean, and this is already happening, it also might mean moving, urbanizing. And in general, I think if you have multiple people living in a single building, the carbon footprint on a per person basis is less. You're sort of sharing heat, sharing food services, so that's another socioeconomic example. But, as the previous chapters have described, change and innovation in the field of energy are a continuous and ongoing process. Very true. Figure 14.1, let's go ahead and pull that up. Okay. Figure 14.1 shows that it's a set of timelines for environmental issues and various technologies discussed in this book. If a transition to a low-carbon world within the next few decades seems revolutionary, then it is only necessary to look at how many other past energy revolutions have happened on a similar time scale. So, that happened with electricity. So let's just go all the way back to 1850, and I'll just grab lighting, for example. So candles and gas lights were prominent. Incandescent lamps, so that's the Thomas Edison glowing filament, tungsten filament, what have you, of the turn of the century. Fluorescent lamps came on about 50 years ago, and now LEDs and CFLs are providing higher efficacy, so more lumens per watt. Okay, what's another one? Let's look all the way down at the bottom. So nuclear power, you can see how that technology was, developed, invented in the 50s, and has a future. They're looking for fast breeders. When you take this was actually in 101. We talked about a little bit about the use of thorium. It sounds like Bill Gates has an interest in uranium-239. There's still a lot of plutonium built up, as we know, so again, these technologies just sort of evolve and perpetuate. Yeah. And on the renewables, you can see how you had hydropower in factories, and that was more or less just mechanical, the sort of, pre-electricity, if you will. Bioethanol was a deal back 100 years ago. Hydroelectric came on in a big way. The tidal barrage, these guys are a big fan of. There's PV. Wind turbines continue to grow, and then biomass, combined heat and power, and then finally the hydrogen economy, which I would love to see happen. In fact, sounds like Joseph might be interested in helping us fix the hydrogen trucks. That'd be a great project. If anyone wants some undergrad research in the spring, maybe get Joseph and get our own hydrogen truck up and running. Okay. All right, so the next thing is 14.2. 14.2 is cleaning up fossil fuels. That's on page 573. And what they mention here are several of the big pollutants. So particulates, I don't know if you read the news today, but Beijing is like as big a mess as ever. People not allowed to drive. You got to stay indoors. So I mean, there's a giant layer of hot, wet air mass over the city, sort of keeping all that crap right down on Beijing. So these poor guys are living the nightmare. And what it looks like, I mean, they've just grown so quickly. They didn't, think forward in terms of what, how to clean up their air. I would love to see this biofilter reactor that we've developed deployed in Beijing. In fact, one idea I had for it would be just to put it in a window. It needs a fan to circulate air through, and just sit inside your house and run a fan mechanically, biomechanically. So pedal the thing and clean the air up that way. So I think about these things a lot, and that's a very easy way to clean up the particulates. Very easy way to clean up the particulates. The SOx, the sulfur dioxide. If you remember, the sulfur is actually coming from the amino acid cysteine. And this is going to be the case in any old or new biomass. I love looking at this because you're like, where does the sulfur come from? Well, we are burning biomass, and biomass was originally comprised of a lot of plant and animal tissue. Plant and animal tissue is comprised of, well, the proteins themselves are amino acids, and so if you look, right down here is cysteine, one of the 20 amino acids, and there's sulfur right there. So all that sulfur that was powering life tens of million years ago is now an issue when burned. And I think to a large extent it's been handled in this country, and in fact it says right here, today over 90% of world sulfur production is recovered from oil and gas. So here's a nice big pile of it. Sulfur removed from the Athabasca tar sands, sitting on the quayside in Vancouver, Canada. So then, obviously, then this sulfur can then be returned to the soil for fertilizer. Okay, the next one mentioned is nitrogen oxides. We're going to have the same issue. We're going to build a rocket stove for next year's practicum, and what the book says here is that the nitrogen oxides result when the combustion temperature is greater than 1,500 degrees Celsius. Pretty hot, but really what's happening there in your NOx reactions. So if we go to the dynamic periodic table, let's hit the dynamic periodic table. So as we know, 80% of the atmosphere is nitrogen. There it is, sitting right there. I'm gonna take a look at that bond. So let's look at the periodic table really quick. We'll look at nitrogen. I always like to look at the orbitals. So there it is. And you can see that 2p shell. It's got 3 up arrows right there in the middle. So for nitrogen, right there, 1, 2, 3. Those are 3 unoccupied shells in the nitrogen bond. In the atmosphere, nitrogen is diatomic. It's 2 nitrogens put together. It's just not a free nitrogen hanging out. This triple bond is very strong. It's very energetic, and that's why it takes that high temperature to pop that thing open. Once you do, it's going to then bind, react with oxygen, which is also readily available, and make your NOx. And if we just go and take a look at NOx, and the reason for the X just means that you could have any number of different oxygens hanging off of there, and it's not a stable. So NO and NO2, so nitrogen oxide and nitrogen dioxide, depending on how available. So if the combustion is sort of starved for oxygen, it's very similar when you see carbon monoxide and carbon dioxide. So there's your high temperatures. So that's something we're going to have to look out for in our rocket stove, because we don't want to have a very efficient technology that's making a lot of heat from very little fuel and then start causing NOx emissions. In fact, I was just on the phone today with someone from the Montana DEQ about what type of sensor we need to purchase so that we can optimize that for our project. Carbon dioxide, of course, it says there remains the extremely serious problem of carbon dioxide emissions, which are unavoidable when carbon-based fuels undergo combustion. That's right. In order to get energy out of carbon fuel, it has to be set on fire, and fire is combining oxygen with it. So here comes your CO2. So it is likely that worldwide CO2 emissions will need to be reduced by around 80%. It's huge. Huge. Well before the end of the 21st century, if there's a reasonable chance of limiting global warming to 2 degrees Celsius against its pre-industrial levels. Okay, so that's the technological challenge that we faced. It says they can be reduced through the improvement of energy efficiency. So you're still going to make the CO2, but you just get more bang for your buck. Rocket stove is one example in the case of heat. You also get a little bit more bang for your buck with gas-fired power plants, and I would be very surprised if we don't see the fossil fuel industry start to gasify coal. I can see where you might even have a station where you've got solar energy coming in to get it hot, it gasifies, and then you're now making methane, CO, other flammable gases that are then burned, because I think it's just going to be a cleaner burn. And what I would love to see happen is have these stations be smaller and more distributed and cleaner, and sort of get away from this big grid type deal. And that way you can then do district heating with it. So the other thing that comes along for the ride, something's going to get hot no matter what. And so what I can see happening is using district heating rather than every single person having their own little boiler, et cetera, but just sort of large underground vessels of either hot water or cold water. Okay. So they mentioned going to low carbon fuels. It says, however, the next major step to decouple carbon dioxide emissions from fossil fuel combustions involves the use of carbon capture and storage technologies on a large scale. And that's what we've come up with. I can show you, let me just show you a little shot of that. Just put a lot of time into this. I'm just going to, I know I've referenced this talk a couple times, and I even mentioned it today on the radio. This is the talk I gave in Billings a couple months ago. So the book just mentioned we need to do carbon capture on a large scale. We've done a little bit, oh, here's me capturing some carbon on a small scale. This is sort of inside, and if you guys get a chance, Craig Thomas is a close friend of mine here and has done a lot for responsible forestry management in the state of Montana. This book is for sale in the bookstore, and it's a fantastic read. But this is more or less what's going on inside this bioreactor that he and his colleagues have built. This is Algae Aquatech up in Flathead. They've got actually a carbon negative powerhouse is what they call it. And then this is how we'd like to deploy the biofilter. So this is a plant like coal strip, and we're actually taking the filtration material that you see here, putting it in large containers, and then sequestering the CO2 from the coal-fired power plant. And so we're getting the beetle kill out of the woods, putting it to work as a filter, and now it's sequestering carbon. So
You're performing 3 jobs.
Exactly.
One thing. Now, can that sequestered carbon in that material, can that be reused to reintroduce to soil to help get more minerals for our topsoil and stuff like that?
Yeah, so you'd want to have a mercury scrubber, heavy metal scrubber, but the idea would be exactly that. So then you turn that material, that biomass, into biochar, and from what I've seen, biochar is just a miracle drug for soils. Yeah, so it's still still part of the carbon cycle. I mean, we're not doing atomic physics here. The carbon atoms themselves are just little nano coins. They're just little trading units. But you're exactly right. We want to take that carbon and put it back into the soil and into the biosphere rather than letting it float around in the air, causing global warming. Yeah, great question. Okay, so I feel like we're addressing what the author has just said here in a pretty big way, and have the potential to let the coal-fired power plants sort of die a long natural death, or just be used as backup. Just don't burn them 24/7. Okay, fossil fuel switching is also mentioned. So combined cycle gas turbines, high efficiency, they were described in 9.6. In general, CO2 goes down when you're using that. One issue, and it's a little bit of pick your poison. You want to dig for coal or frack for gas, and it'd be nice to be able to move away from both of those. Okay, clean coal. I was just at the Clean Coal Conference, also in Billings. Max Baucus was there. A lot of other dignitaries there. A lot of people from the Department of Energy, many of whom I've had a chance to talk to. And CCUS is really at the heart of this, and there are many different flavors of that. But let me just show you what the book has in mind.
They have strawberry lemonade. I'm sucker for strawberry lemonade.
Oh, where's that?
You said many flavors.
Oh, there might be a strawberry lemonade. In fact, that's how Blue Marble really launched. They were trying to make biofuels from algae in the ocean, and their process was good enough and clean enough that they were making food grade additives. So it wasn't strawberry, it was blueberry, but could be.
I like it.
Yeah, if this. So, depending on exactly where in the stream you are, you might be making food grade materials. One example, even right here, this TARS loop. So, one place that TARS go is into road surfacing. This might be of interest to you too, Rain. There was a book out there. It's called MAUVE.
MAUVE, M-O-G-G?
MAUVE, M-A-U-V-E. I might even have a copy of it. So, and I don't remember exactly when this all took place, but there was a big problem. This was in England. Big problem even then with industrial waste. And what this gentleman recognized is that there was this nice purple color to a lot of it. So he took the tars and the nasties coming out of the industrial waste and started coloring women's clothing with it, and made a bunch of money. 'Cause, this is back when people were wearing burlap bags and only the royalty could
The color
afford.
love,
Yeah,
that purple.
yeah, exactly. So anyway, he turned an industrial waste stream into a fashion revolution, if you will, a couple hundred years ago. So
That's neat.
yeah. So again, you sort of see all this cleanup, tars, et cetera. There's a place for everything. We even saw that giant pile of sulfur that's going to go back into
And that is one of the
agriculture.
reasons I wanted to get up to your house, because I've got access already to a bunch of good materials and normally just fill up our landfills. My buddy's got a glass crusher.
Oh, yeah.
And it's piles of glass, so I want to use that as part of my landscaping material.
Oh, yeah.
I also want to see what else can be done with the different stuff.
Yeah,
And just as biodegradables as well, as what you're doing with that type of stuff.
yeah. Well, I'm happy to have you. Yes, we're going to do a little bit of that in 6 days up at 8 Columbine. So here's your coal. And I did mention previously, I think we're going to see a lot of coal gasification happening. So dirty syngas, it gets clean, it's partially clean, sulfur comes out. Now you've got your clean syngas, so you still have, so the carbon's still coming along for the ride. The hydrogen is there. Once air comes in, that's your combined cycle gas turbine, and then what's coming out, well, just your standard flue gases. And if we get our act together on our biofilter, all of this would then go through that filter, and the CO2 does not go into the air. It's pumped into our filter. You could see algae growing with it. I could see putting that CO2 into greenhouses. There's another entrepreneur here in town who's looking into the CO2 market for breweries. That some of them buy $250,000 worth of carbon dioxide a year, but then also emit a lot as well. So the idea is let's just keep those CO2 emissions from being emitted in the first place, and save money and don't emit CO2. So you've got a win-win. What's that?
Serve flat beer.
Supercharged, recycled CO2 beer, yeah. No, if you start serving flat beer, there will be a revolution, a revolt, yeah. So, and I think another thing to note, and I'm going to take one more moment to show you a lab. If you guys want to kind of follow what the big boys are doing, Chalmers. So Chalmers is kind of like the MIT of Sweden, if you will. And I don't know a whole heck of a lot about what's going on here, but what I think is going on is they're doing a full gas capture as well. So they're getting heat out. There's some combustion going on. A lot of catalysts. I was reading up a little bit, and they've got a lot of catalysts that allow some of the reactions we were seeing with the syngas to happen at lower temperatures. So pretty high tech. The point I'm trying to make here is that as we move into the future, things will become more complicated. Computers become more complicated, financial models become more complicated, your healthcare bill becomes a nightmare. I mean, it's sort of inevitable. And so, as energy technologists, it's up to us to embrace that and enable it rather than, looking back to the dirty tech. So I see what these guys are doing here in Sweden as a way forward. And if I get my Fulbright accepted, we'll see, hopefully, then maybe I can actually work with these guys and bring some of the technology back to the U.S. Because, every time I've been to Europe, you come back and you're like, man, we are really behind a lot of this stuff. So.
It's so crazy that we are that far behind.
Yeah.
We're supposed to be the forward thinking.
Yeah, well, it's weird. I mean, we are. I think we're way out in front on a lot of stuff. But for whatever reason, our power grid's antiquated. A lot of our transportation is pretty antiquated, and I don't know exactly why that is, but I think we're in a position now where we can change that. Okay. So things get even more complex, as I just mentioned. But this is just the a conventional coal-fired power plant. Some of this is happening in Wyoming already. There are CO2 pipelines between Wyoming and Montana, so it says to sequestration. A lot of that's used for enhanced oil recovery. So the CO2 is just being pumped underground. It won't burn, it won't get hot, so that's one reason for using it. And then up comes more carbon. Here's the coal-fired oxy-fuel plant. So you still have coal coming in, you still have air coming in. The nitrogen is pulled off earlier. Some kind of electricity has to come out of there. The flue gas then goes to a condenser. So there's a lot of water. Water is one of the other combustion products, and there it is. Who doesn't like water? Sulfur comes out, and then the CO2 off to sequestration. The next one in C is the coal-fired pre-combustion capture, so IGCC-CCS. Coal still comes in, oxygen is still going in, very similar to what we saw earlier. Instead now you're pumping in steam, which creates this so-called shift reaction. So you're taking the oxygen and the hydrogen off of the steam, and now some H2 comes off, the hydrogen sulfide, and then you're more or less cleaning up that CO and turning it into CO2, so that oxygen shifts from the water over onto this carbon monoxide, changing it into carbon dioxide. Hydrogen comes off. That's a good thing. That can then go into your combined cycle and make electricity there. And then finally, there's just the straight up natural gas, so there's no coal involved at all in this lower one, relatively simple. In each one of these cases though, what we would like to do with our biofilter is just take this CO2, 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 run it through there, and now we've taken care of that problem. As I said before, that can then go back into the soil. So you're still making electricity. Okay. Yeah, and as I mentioned, the shift reaction, pull, and that's on page 580, sticks another oxygen on your CO, and then the H2 comes off. Okay. Now, this type of thing has already begun to happen. There's the Kevin Dome project. Which is already underway. So similar to what we're seeing here, you've got some big rock formations that will basically allow us to re-inject CO2. So you can see it sort of going back underground. Here's the one in Montana, Kevin Dome well site. So inject 1 million tons of CO2 into the regionally extensive Duperow carbonate formation. I'm always a little skeptical about these, and I'll tell you why. If you also get a chance over winter break, you might consider reading this book. Not the most uplifting title, but there it is. In this book, the authors reference a natural disaster that happened in Africa not too long ago. And let me find that one too. CO2 lake in Africa. Lake Nyos. And I'd never heard about it, but it was in the 1980s somewhere.
1986.
1986. A pocket of magma lies beneath this lake and leaks CO2 into the water, changing it into carbonic acid. Nios is one of only 3 known exploding lakes to be saturated with CO2 this way. So, you know how when you open up your carbonated beverage, we were just talking about beer a second ago, the bubbles come out, right? So at some point, there's so much CO2 saturated in the water that it goes from being dissolved in the water into forming, it goes from a liquid phase into a gaseous phase, and there's your explosion. Not unlike just boiling a pot of, yes, unlike boiling a pot of water, but the same thing, you've got these bubbles, coming off. Now what happened, August 21, 1986, possibly as a result of a landslide. So what you're hoping does not happen is that some kind of seismic event pops open Kievan Dome and your 1 million tons of CO2 come out and blanket the surface of the Earth. I mean, again, it's pick your poison. Do you want to be slowly cooked by it in the atmosphere or just suffocated instantly? Because that's exactly what happened to these people. 17,000 people, or 1,700 people suffocated, 3,500 livestock, because the CO2 is heavier than air. It's got a greater density, and so it just hovers near the ground. And yeah, unless you have an oxygen mask on, you're dead. So first known, historical siphons, et cetera, et cetera, et cetera. So now they've got some technology there to more or less siphon it off. But the well is leaking, geological tremor, levee give way, not so good, downhill villages, yucky, yuck, yuck. Okay, so that's my own reservation about this type of technology, because all right, it's got to go somewhere. big lethal bubble underground. All right. Okay, let's take a quick break here. 37 minutes.